We have to figure out this statistic stuff.
What? Wait, we had statistics stuff?
Yeah, in chapter 5.
Chapter 5?
Yeah, man. It says an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses.
Like a sample, man. A sample is like part of the population, right?
Yeah, Zach. It's like when you want to answer a question, you'll take a part of a population. Like maybe we want to know if people in North Carolina like iced tea or lemonade. So we'll take a few of them, we'll ask them, and that'll give us more information about everybody. And then sometimes when you want to ask the whole population, and you ask every single person, that's called a census.
Wait. Who are you?
I am a statistics teacher.
Do you know him?
No, man.
What about you? No? Right on.
What about bias?
Bias?
It says a study is biased if it systematically favors certain outcomes.
Oh yeah, I know what bias is. They say a sample can be biased if it's a voluntary response or a convenient sample.
I thought I brought everybody here. Where'd they go?
I'm just always late.
Ah, well, finally you showed up. What about Cameron and Deshaun?
I'm here.
Where's Deshaun?
He's absent.
Alright, I won't question that, I guess. So, anybody, you guys remember what we were talking about with the difference between the population and the sample?
Is the population like a whole bunch of people that you would be sampling, and then the sample is like a couple people?
That's not too far off. The population is everybody that you're asking about. So in that question about how many people in North Carolina like iced tea versus lemonade, everybody in North Carolina is your population. Your sample is how many people you actually ask to figure out how many people like iced tea and lemonade in the whole population. Make sense?
Yeah.
Alright, but there's a whole bunch of different ways to get to your samples. So Zach, what do you know about sampling methods? Tell me about an SRS.
SRS is just a random taking of a small part of the portion, right?
A simple random sample, man.
Yeah.
Exactly. So it's totally randomized where you're just picking the whole population and you randomly choose people and you ask them the question. So once you get down to stratified sampling, that's when you got to put people into groups. So it's the strata, you break them into different groups based on similar characteristics. So for example, how much money people earn, how old people are, and then you would totally do your SRS among the samples instead of just among everybody. So if you have like 4 strata, you'll randomly select from each strata. Make sense?
Yeah.
Cluster samples are when you get a whole bunch of groups that are representative of the whole population. So they'll be all different sorts of people, just like the whole population is all sorts of different people. And then you'll just pick one of those clusters, and that'll be your whole sample. Make sense?
Yeah.
Alright, what do you know about systematic sampling, Zach? Alright, fair enough. Systematic sampling is where you got a certain method for choosing your people, like maybe every 5th person, like with exit polling. Whenever somebody walks out, they'll ask every 5 people who they voted for, and that's how they make their projections. Make sense?
Yeah.
Probability samples, that's where you want your sample to be representative of how many people are in your whole population. So maybe you've got like 30% of your populations between the ages of 20 and 30. So then you want 30% of your sample to be between 20 and 30. Make sense?
Yeah.
Sweet. The real issues with sampling are whenever something's going wrong, you got all sorts of sources of errors and bias. So you got to be able to watch out for those. What do you know about undercoverage, Cam?
not covering your whole sample, right?
Yeah, exactly. Your sample isn't covering the population. So you gotta be careful with that because you don't want to ask all of your questions on the phone or something when people are at work. Because then people won't be able to answer their phone and you miss all of the workforce. Make sense?
Yeah.
Alright, and non-response.
I know this one. It's when people don't respond in your sample.
Exactly. And that could be a huge problem because then you're missing a huge chunk of your population that you're trying to represent. What about voluntary response? You got anything for that?
I forget, man.
That's alright. Voluntary response, that becomes the source of bias when if you ask, say, 300 people over the phone to just call you on the news station, you'll be like, here, call this number. Only the people that really, really care about the issue are going to call. So you're only going to get the bias of the people who care a lot for it and the people who care a lot against it. You're going to miss everybody.
Okay.
What about convenience sample?
Isn't that when the statistician just asks the people that are close by so it'll be easy?
Exactly. So maybe like a high school teacher wants to do something like that, and he just asks his whole class. That's not really representative of the population. It's just that's who's right next to him. And then there comes entirely worded questions. Kind of self-explanatory, but it's basically when the question itself that's being asked misleads the answer in one way or another. That's especially for hot-button issues, like maybe social justice issues. People will word the questions so that you're on their side. That's
So,
not-
like, in our question, if we were like, do you like the best sweet tea in the world or lemonade?
Exactly. Because that's going to make it so people want the best sweet tea in the world.
Gotcha. Thanks, man.
Heck yeah, good luck on that test. Hey, Sean might have some trouble.
Doctor, I have a serious problem.
What? What's going on with this? Oh my! There's no color!
There is no color. Color has been expelled from the freaking world.
I know what we must do. It's time to conduct an experiment.
What kind of experiment could you do? We're talking about the whole world here with no color.
Calm down, calm down. That's not our issue right now. Right now we need to figure out how to recover the pigmentation on a small scale. I suppose typically we'd have a few options here. We could do an observational study, which would be if we just looked at pre-existing data and drew our conclusions based on that. But this is a brand new phenomenon that wouldn't even exist. We'll have to design our own experiment. We'll need to incorporate some random allocation. We'll need to have separate groups for their treatments, administer different treatments to each group, and then look at our results to see which will work better.
What exactly does any of that mean?
Let me explain. So you see, the most important thing to get reliable results, to make sure that the experimenter themselves, us in this case, wouldn't be influencing, is random allocation of whatever you're treating into their different groups. So you begin with some form of randomness, perhaps the flip of a coin, or the roll of a die. And from there, once you've formed both of your two groups, I suppose what could we use in this case? That is the issue at hand. Maybe if the issue is pigmentation of the entire planet. Perhaps leaves. Leaves. You could use those. Their natural pigments will hopefully respond to whatever treatments. As such, it would be natural to use chlorophyll, the plant pigmentation. That would be the first treatment.
Wait, what about, don't you mean like a control group or something?
Typically that may be true, but since we're comparing two different administrations of treatments, we can just use the comparison of the results to see whichever is better.
Okay. I think you're onto something.
Alternatively, we could use perhaps a human pigment, melanin. That should do nicely. From there, we need merely administer it to the leaves themselves. Then we shall have our answer. Perfect.
This just might work.
I hope so. I really hope
So, the experiment?
Yes, of course, my apologies. As I said, we need to begin with the random allocation of the groups. So now that we've collected our samples, you have a coin on you, perhaps?
Yeah, got one right here, quarter.
Perhaps not. That may not be best. For example, if we were to use a coin, then we could have one group fill up too soon, the rest would be skewed results. It may be best to just simply pull it out of a hat.
I'll just save this for lunch.
So these first 5 leaves will be placed into the first group. So could you blindly pull these out? Group 1. Wonderful. Thank you. 3 more. Perfect. That does look like a leaf. And that's 5. So this is our first group. This is our second. Total sample of 10. So, next to begin, we must separate the treatments. Here I have chlorophyll, and here I have the melanin. Yeah,
What did you do to me?
it worked!
What?
It worked!
You gave me a headache.
It worked! So, in order to execute a simulation, we need to have some sort of thing that we're simulating. For this example, we've heard that the C.B. Jones Auditorium is haunted. And from what we can assume, there's a 75% chance that someone who enters the auditorium will see the ghost. So in order to simulate that probability, we have this calculator here, and we're going to use the random integer function on this calculator to simulate 8 trials with the values 1 through 8. So we'll assign, say, 1 through 6 as someone seeing the ghost, and 7 and 8 as a failure. And we'll see how many of them actually work. So if you come here and look at this wonderful calculator, I just executed the test, and it would appear that we have 2 values of 8, which are failures, people not seeing the ghost, and 6 values that are 1 through 7, meaning successes. So it would appear based on this that the proportion that we basically just made up is accurate.
There's nothing to say ghost.